Hello, we continue studying proportions. Remember from the previous lesson, proportion is when you tie two ratios together, and those two ratios have to stay proportional to each other. What does that mean? We continue our study of ratios and proportions with page 114. Let's take a look at the first problem, problem number 1. It's actually a recipe. Very common. Proportional relationships show up when you scale up or reduce your recipe. I'm sure you've encountered these examples in real life. Let's read the recipe. To serve four people, we need 2 eggs and 3 slices of bread. Fantastic. 2 eggs and 3 slices of bread. Now let's take a look at the question. How many eggs and slices of bread will serve 12 people? Again, we can do this with bar models, but I'm going to suggest sticking with the same setup. Set up your proportions. Yes, we can do the bar models, but I would like to show you a slightly different, simpler way, less drawing. So, what is given? 4 people are served with 2 eggs and 3 slices of bread, right? That is given. Now, what happens when we increase the number of people? We want to scale up the recipe and we want to serve 12 people. Take a look what happened. We triple the number of people. Therefore, makes total sense that we triple the quantity of food, right? Times 3, times 3, times 3. So we will need 6 eggs and 9 slices of bread. We're tripling our recipe, right? Really nice. So to serve 12, we need to triple the number of people. Therefore, we triple the eggs and we triple the bread slices. I think that's pretty self-explanatory. Now, let's take a look at the following example, part B. I'm going to pick up my orange. How many eggs and slices of bread will serve 2 people? So instead of 12 people, we now have only 2 people. Obviously, we need to reduce, we need to scale down our recipe. Well, 4 people, that was given, right? Notice, again, I'm going to write down my proportional relationship. First, the given ratios. For 4 people, we needed 2 eggs and 3 slices of bread, right? 2 eggs and 3 slices of bread. What happens if we want to scale down a recipe just down to 2 people? What happened? We halved the number of servings. Therefore, we must proportionally reduce the quantity of food. So there will be 1 egg and 1.5 slice of bread, right? Slice of bread times 1/2 times 1/2. Notice, to serve 2 people, we have to half the recipe. Therefore, we need to have half the quantity of eggs and half the bread. That's what it means to stay proportional. What you do to one quantity, you must do to another. Let's take a look at another recipe, very often showing up in recipes. We are in problem number 2, making lemonade, of course. Let's read. To make a lemonade, Jane uses 1/8 as much. Notice this language. We've seen it a few lessons ago. Jane uses 1/8 as much concentrate as water. Now think about a recipe for lemonade. You always have to have a little bit of concentrate and then you dilute it in a larger quantity of water. In this particular recipe, how much concentrate does she need to make? 720 milliliters of lemonade. Let's set up what is given. First of all, we need to need 1/8 as much. That means concentrate to water. Actually, let me use H2O. Here is our given ratio. 1 part concentrate, 8 parts water, or 1 to 8. To have 1/8 as much concentrate means 1 to 8. So we have 1 unit of concentrate. We can use bar models. if we want to, and 8 units of water. That is what is given by the recipe. Otherwise, your lemonade might not taste just right. So that is a given ratio. Let's find out. If we need 720 milliliters, what happens if we need 720 milliliters? That means altogether we have 9 units, right? Step 1. 1 plus 8 gives you 9 units or 9 parts. Sometimes people say 9 units. Therefore, 720 milliliters divide by 9. Step 2. 720 divide into 9 equal parts gives you 80 milliliters in each unit. Let's write it down. 80, 80, 80, 80, dot, 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 meaning so on, 80. Therefore, how much concentrate does she need? She will need 80 milliliters. 80 milliliters. That is our answer for this problem. 80 milliliters. Now, because that was the question, how much lemonade, how much concentrate does she need? Next part of the same question, part B. How much concentrate does Jane need to make 101.8 liters of lemonade? Notice our quantity is not the same. We want to make more. My friends, here it is very important to convert 1.8 into milliliters. Let's recall 1.8 liters is the same as 1,800 milliliters. Now, you don't have to convert it. You don't have to convert it to milliliters. I think the math is simpler. You don't have to deal with division by decimals, but you can keep it as liters and work with decimals. So again, our question is, how much concentrate? Notice what is given, our original ratio, 1 to 8, did not change. The recipe stays the same. Now, but we have 9 equal parts, right? So step 1, 1 plus 8 gives you 9 units total. And step 2, 1,800. Divide into 9 equal parts. Each part will have 200 milliliters. Let's label it. For this recipe, we need 200, 200, 200, 200, dot, 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 and so on. So how much concentrate does she need now? She needs 200 milliliters of concentrate for this recipe. And now off to the third part of the same question. How much concentrate does she need to make X liters of lemonade? X liters. Notice, now we have a variable, but the problem that is given is still the same, right? We have 1 part concentrate to 8 parts, or 1 to 8, the same ratio, right? The same ratio holds this key given information. So, what do? We follow the same logic. Step 1. In total, we have 8 parts, or I call them units. Now, to create X liters of lemonade, we need to divide X by 9. And we can write it in 2 different ways. We can say X over 9, and that is not a preferred way. The preferred way is to write 1/9 of X liters. And that is our answer. 1/9 of X. Let's label it. 1/9 of X. 1/9 of X. 1/9 of X. Remember, when we did our fraction unit, I told you that it's very customary to use a coefficient in front of the variable. Although, if you write X over 9, it is not terribly wrong. Whichever way you choose, ask your teacher what he or she prefers. I hope you found this helpful.